The Vernier Caliper is an accurate measuring instrument, and the one we see in this illustration has both the metric and the SAE, or as they call it, inch scale, on it. As far as the inch scale, or the SAE scale, it can measure accurate to 1/1000th of an inch, and in the metric scale it can measure accurate to 0.02 millimeters. There are two jaws, the movable jaw that is attached to the Vernier scale, which we're going to examine, and the fixed jaw you see at the far left that is attached to the number line. And these are all indexed very accurately to allow the technician to get an accurate measurement. The key to the accuracy and versatility of a Vernier caliper is due to the Vernier scale. And the Vernier scale moves with the movable jaw, and it is calibrated in such a way that allows these readings to be accurate. And that's what we're going to look at first. The one difference in the Vernier caliper we're going to look at is the SAE is on top, and with the Vernier scale for SAE, and the metrics on the bottom. But we're just focusing on the SAE and not the metric. That's in a different video. In this illustration, the blue is the fixed scale, or the number line, and you can see the divisions there. There's the first set of notches are 25 thousandths, or 0.025 notches, very similar to a SAE micrometer. And you can see there the blue numbers are actually on the Vernier number line. Up above is the sliding Vernier scale in red, and you can see it's kind of numbered a little differently. It's numbered actually 0 to 25 divisions. There's 25 divisions on it, but they are altered slightly. And here we see just the 0 to 5, 6, 7 notches on this Vernier scale, which of course slides with the movable jaw. What's important to note here is the size difference, or the fact that the Vernier divisions are 1/1000th short of 50 thousandths. So if you looked at the Vernier scale on the larger picture, you would see there's 25 divisions. So the entire Vernier scale is short 25 thousandths, because 1/1000th times 25 divisions is 25 thousandths. So I've added to the illustration, and you can see as you go down the Vernier scale, each division is short 1/1000. So as we go down, you can see in the illustration that for every notch on the Vernier from 0, there's an extra thousandths that it's short. So if we lined up, we just opened up a little and lined up the 3 thousandths, or the third division on the Vernier scale, as I've shown here, just so it lined up, that means we opened the Vernier 3 thousandths just because it lines up with a line. We don't have to know which line it lines up with, because it's always in a range of 2 notches on the fixed scale. So if we were measuring something that was 3 thousandths of an inch, we would look to the Vernier to see where it lined up. And if it lined up with the 3 thousandths or on the Vernier, or on the Vernier scale, that means our measurement is 3 thousandths. That's basically how a Vernier scale works. It's a little hard to conceptualize, but that's how it works. And furthering this Vernier action, if line C on the Vernier scale lined up with D on the fixed scale, that would mean whatever we were measuring was 5/1000 of an inch. So it's just a matter of believing or understanding how these vernier scales work when they line up with a respective line on the fixed scale. And that's how we read the vernier. Whatever one lines up from 0 thousandths to 0.0000 thousandths to 0.024 thousandths, whatever one it lines up with is our vernier reading. So we're going to look at this reading here both in actual pictures, or this picture, and in a drawing. And what we're looking for is a process so that we can get an accurate measurement. So we have to go in steps. And here we can see, or we'll refer to this when we want to see which line lines up on the vernier, but I'll get back to this. So step one. So on the 0 on the vernier scale, we see which whole inches that the 0 has gone by, and we look here and we see 1. So 1 inch has whatever we're measuring, it's bigger than 1 inch. That's step 1. Step 2 would usually be the hundreds of thousandths of on the scale, but we're going to skip that for this example, and we're going to go to the notches past the 1, which is 1 notch. If there was 3, it would be 0.075, but there's 1, and so we add 0.025 to our total. So the next step is the vernier scale. Now we look for a number that lines up, and when it lines up with that number, we read the vernier scale in 1/1000ths of an inch. And we look here, and the vernier scale is lining up with a line on the fixed scale, but we just read the vernier at this stage, and it is 4/1000ths. It lines up with the 4/1000ths on the vernier scale. So now we got all our steps done for this example. And our total is 1.029 inches, accurate to 0.001 or 1/1000ths of an inch. Our next example is a little bit more involved, and we need 4 steps because we involve the 100,000ths also. So we look at this Vernier Caliper reading, and we're going to look at it in a real picture like this, and then a close-up, and then we're also going to look at it on a piece of paper so we can work it out. So I'll just show you this. Here's a close-up, and we can see we're past the 3 inches and not at the 4 inches yet, if you look carefully here. And so let's look at this on a piece of paper. So here's step 1, and that's just reading the whole inches, and that's 3 inches. And kind of didn't draw this in too much detail because it gets kind of complex, plus it's very hard to do. But we do know that 3 inches has been passed by the 0 of the vernier scale, which is slides when we do our measurement. And remember, you have to have the right angle when you look at it. These are little A, B, and C eyeballs there, and B is the angle you want. You want to look directly down on a vernier to make sure you get the proper scale. So anyway, step 1 is 3 inches. Step 2 is the hundreds, and we didn't do that last time. So after the inches, we look for how many hundreds, and there's 9 hundreds. And you got to look carefully here. There's 9 hundreds, and so we have to add that to our total. And you can see the 0. There's the 8, and then 9 hundreds, and then of course 4 inches. So so far we have 3.900 inches. Step number 3 is the notches, and we did do that last time. And we look carefully here. Now we see the 900. We've accounted for all of that, and the notches past the 900. and there's 2 notches. And to complete, they have to be complete, so we have to add 0.050, not 0.025 or 0.075, but 0.050 representing the 2 notches. And finally, step 4, which is reading the Vernier scale. And if we look at there, I got it where it lines up. And if we look at the real life example here, you can see that it lines up with the 23. It's very close, 24 and 22. But you would be able to tell the difference when you look at it carefully. And remember, your eye has to be directly over it. So we end up with 3.973 inches on this example. Well, here's an example, and we look at the top. We can see the 1 inch there. So here's a better view, the 1 inch, and then we want to do our 4 steps. So if we go back and look at the blow up, we have 1 inch for the 1.00. Now there's a little, trick, is a bit of an estimate here. We see the 400,000, so we know we got 1.400. But then the notches is where we have to do a bit of an estimate, so we know where to look on the vernier. And there's 2 complete notches, and that 0 is about halfway through a notch. So we're going to be looking around 12, or around 12 to 15, somewhere around there. So now we have 1.000 plus 0.400, and the notches are 2, so plus 0.050. So we've got 1.450 so far, and I think the 15 thousandths lines up the best. I mean, depends on your eye angle, and so we would end up with 1.465 inches with this measurement. So let's see if we can work this out. This is the final example. So use the 4 steps as you saw previously, and use the pause function in your computer if you have to. And step number 1, of course, is the whole inches. Step number 2 is the hundreds inches, hundreds of thousands of inches. So you add that into the total. And step number 3 is the notches past that last 100 reading that you got. And I'll give you a little hint that this is just past one of the notches. And then finally, step 4 is the vernier reading. And of course it'd be very small on this example. So I'll let you work it out. And thank you very much.